Hello, class, the receiving students and teachers. Thank you. You may be seated. We're still on the same strand, substrand, same outcome, unit title. Now, we recap just a simple question on the lesson that we had yesterday or the previous lesson. You have to name the non-metal substance that can conduct electricity. We know that we have learned that all metals conduct electricity, or they are good conductors of electricity. There is one that is not metal but can conduct electricity. What is that substance? If I can have someone from the class, receiving students, please, you give your answers to your teachers. Yes, thank you. Mike.
Carbon.
Carbon, good, thank you. Now, class and receiving students, I also gave you homework. Your homework was to find out what you can about expansion. Expansion. Now, if I can have someone from the class to tell me what expansion is. Receiving students, you do the same too. Yes, thank you. We have a hand up at the back. We'll have you.
The action of an instance of expanding.
Good, thank you. Anybody else? There's another next to what he has. Juanita?
Expansion, make or become larger or more extensive.
Very good, thank you. So I won't say one is correct and one is not correct. They are both correct. And I hope our receiving students, you have also done the same. Now let's see. Our topic is expansion. And you've already given me, two of our friends have given us their definition of what expansion is. Now let's see. We are going to be doing experiments using solids, liquids, and gases. Let's see the definition that we have on the screen. Scientific definition: the change in size of an object or material due to temperature change. When the temperature changes, it makes the object or the material change its size, become larger or increase, like your friends have said. I have that one copied quickly, receiving students, together with the class. Now, experiment 1 is going to be on expansion of solids. We have a picture. There's a picture showing an example of what or how expansion takes place in solids. Our experiment 2 will be on expansion of liquid, and 3 will be on expansion of gas. Now, I'd like you to take note, the class and the receiving students. Before we go to the activity, I'd like you to know how we are going to do the activity. So after we do the first experiment, we will know what to do for the second and the third experiments. Now, first experiment, we are going to be doing it as a class, the whole class. The second, I will have this 1, 2, 4 groups. You will be on liquids. Take note of it, okay? 1, 2, 3, 4. You're going to be doing experiment on liquids. 1, 2, 3, 4. You will be doing experiment on gas. So once we come to those experiments, please, I don't want you to start asking, you mean by walking one, what are we going to do? You should know which experiment you are going to be doing. Now, experiment 1, we are going to view a short video, and I'd like the class as well as the receiving students to take note of what you see on this very short video. Now, you will have questions. You also have, for the model class and those in the receiving schools, if you have received your student worksheet handbooks, you have your questions there in those worksheet handbooks. But for those who don't have the worksheet with you, that is your first question. I'd like you to take note of that. So while you are watching the video, I'd like you to take note too. That is your second question. Straight after the video is over, you will be given 2 minutes to try to answer those questions quickly. Okay, we are going to view that short video. This is a video on expansion of solids. a short video on expansion of solids. You have 2 questions there. I'd like the class, you have 2 minutes to answer those questions. So you work together as a group, quickly discuss, and have your answer written. Discuss together as a group. Let's see what you have as your answer for the first question. Explain your observation of the bar before and after heating. You have seen the bar fitted where the gauze is before and after. What have you observed? Michelle, if I can have you to give us the answer to the first question. And receiving students, please, you also do the same. Give your answer of your observation of that video to your teachers.
Before the bar was heated, it fitted easily into the gauge or where it was supposed to be in. It went easily in and came out easily. But after it was heated, it couldn't fit in because it expanded.
Okay, very good. Thank you. Michelle has actually answered the first question, the second question too as well. The second question is, what you explained in the first statement happened. So she already explained that. Because it expanded when it was heated, the bar could not fit into the gauze or even into the hole of the gauze. Now, experiment 2, what I'm going to do, I will go through the instructions for both experiments. Okay, I have them because they're too much to have it on the screen, so teachers, I have them on the charts. So I will have that up so we can have a look at it before the students can carry out the experiment. Let's see. Okay, this is our instruction for experiment 2 on liquid expansion. Those groups that are going to be doing the experiment on liquids, please, I'd like you to take note of what you are going to be doing. Now, I am not going to go through every step. It's all written out there. I'd like you to read it and you follow and do what it says. We will have the instruction for experiment 3 also up. Now, once again, for the sake of those who don't have the worksheets with you, especially the student worksheet, we have the questions there for experiment 2 up. So please, the students and the teachers in the receiving schools, I'd like you to take note of these questions before we can carry on the experiment. So those are the 2 questions for experiment 2. Have that done quickly into your books or whatever you are using. Teachers, you also try to help the students and get yours done too. Students and the teachers in the receiving school, I will also have the questions for experiment 3 up soon, so you do the same. You have them copied into where you have got the questions for experiment 2 done. Teachers in the receiving schools, I've divided the class up into 2 groups. I have 8 groups, so 4 groups will be working on experiment 2, that is expansion on liquids, and another 4 will be working on expansion of gases. Now, if I can have the runners from each group to come and pick up your equipment or materials. The groups that are on expansion of liquids, you should get the tray that has beaker. Please, can I have you first? Liquid expansion, come up first and get yours. Your tray is the one that has the beaker. The next 4 groups who are working on expansion of gas, you can come and get the remaining 4 trays, 1 for your group. Follow the instructions are there. See that, follow it and do it step by step. That's yours. That's for the beaker. Experiment 2. Here, this one's here. 1, 2, 3, 4.
The beaker.
Yeah, the beaker. The ones with the beaker. Okay, yours is your own gas. Can you help and pass this down to your friends there? Do I feel it right up? The water, do I feel it right up? You rub it until you feel it hot. Make sure you answer your questions. Yeah. You should have all finished your experiments class, and we just go through quickly of your findings on expansion of liquids and gas. Now experiment 2, that is expansion on liquids or liquid expansion. Our first question or statement is for you to explain your observation of the flask of water placed. Actually, we use test tube instead of flask because flask is too big. So we try to use a test tube and we put it in a beaker of hot water. So I'd like the groups that have worked on liquid expansion, if one of you can tell me of your findings. What did you see happen with the water that the test tube with the stopper placed in that was put into hot water? What happened? If I can have someone from the 4 groups who have worked on that experiment. Okay, we have Juanita.
The water level in the test tube increased.
The water level in the test tube increased. Now, second question is this: what would happen if more heat was applied? What would happen if more heat was applied? Rachel? Oh, sorry, who? Rachel?
The cold water in the test tube gets very hot.
Diane, want to add more to that, Diane?
The water will overflow.
Overflow, increase and overflow. Good, thank you. So if I can have someone, please, from those 4 groups who worked on expansion of liquids, if you can just sum all that up. If you can sum up all that. When heat is applied, somebody to sum that one all up for us. Can we have a boy? Because I had girls already. A boy, please. Aquila. Michelle, can we have a boy from your group to give us a sum up experiment 2? Those who did expansion on gas, please, I'd like you to get yourself prepared so we don't spend more time on going through those questions. Okay, let's have you. You. Thank you.
Liquid expand when heat is applied.
So How can you tell that liquid expands?
When the heat is overheated by the water when it is heated.
Okay, good try. Thank you. You can tell by the level of the water in the tube. It increases. Thank you. Let's have expansion of gas. Expansion of gas. Somebody to explain to us what happened or what you have observed. What did you observe? Lisa? Your observation?
When heat was applied, bubble came out from the test tube.
Bubble came out of the test tube. Now, what can you say about that bubble? What can you say about that bubble? The 4 groups who worked on gas expansion. There is something that is coming out in the form of bubbles. I'd like someone to tell me. Those 4 groups are receiving students. I hope you're also doing the same with your teachers. Thank you. Let's have you.
Gas.
Gas. Okay, so what actually happens is that you applied heat by rubbing your hands. And once your hands were warm, you applied that heat onto the test tube. And in the test tube, there's nothing inside. We can't see anything, but there's actually gas in the test tube. So once you applied heat, the gas in the test tube expanded, and some of it escaped, and they came up in the form of bubbles. Now, summary. Solids, liquids, and gases expand when heat is applied, any form of heat. The increase in size of substances when heated is called expansion. What happens to the size of a substance when it's cooled? What happens to the size of a substance when it's cooled? Yes, Michelle.
When the substance is cooled, it gets back to its normal size or it contracts.
Very good, thank you. Our last summary point, the decrease in size of substance when cooled is called contraction. A key word. I can have someone to give me the key word. Okay, let's have Lisa.
Expansion.
Expansion. Okay, let's see if Lisa is correct in there. Expansion is a key word. Our next lesson will be on acids. Let's find acids. Now, there are materials that you will have to help your teachers to collect, students in the receiving schools, as well as the class. Take note of all the materials that you are going to help your teacher to collect. For your teacher to get all those, that is too many. That's too much or too many for the teacher. And I encourage the students in the receiving schools as well as the students in our class to help your teachers to collect what you can so your teachers can use that in our next lesson. And with that, thank you all for your participation.